Okay, president versus committee. So, let's say, for example, let's go with a simple example in the notes. How many different ways can we organize 3 people? Well, that's simply just blank times blank times blank. We have 3 people to choose from, then 2 people to choose from, then 1 person to choose from. We also call that 3 factorial, which is 6. And we could list all the number of ways. So now let's look at the second example. A class is voting on a president, secretary, and treasurer out of the 10 people running. How many different choices are there? So we have 10 people to choose from. I'm just going to write 10 and circle it. So we have 10 different people to choose from. So I'm going to do blanks. Blank times blank times blank. So we're choosing 3 different positions. Let's choose the president first. Well, we have 1 to 10 people to choose from, which is 10. But now we've chosen one of those. So now we only have 9, then 8, for a total of 720. Now there's a different way we can do this. Let's use permutation notation. So I'm going to write the formula. NPR is equal to n factorial over n minus r factorial. And I'm going to substitute. So I have 10 people to choose from, and I'm choosing 3 of them in a particular order. It matters who's president, who's vice president, who's secretary. It matters if the different person is president, etc. Particular order matters. 10p3 equals 10 factorial over 10, open bracket, 10 minus 3 factorial, which is 10 factorial over 7 factorial, which is 10 times 9 times 8 times 7, and then I can close the factorial, over 7 factorial, cross off the 7 factorials from the top and the bottom, and I get the same 720 as I got previously. So now let's take a look at another example called a committee. So now we're voting on a committee of 3. So again, we have 10 people, and we're choosing a committee of 3. So, with a committee with C, blanks do not work out as well. So, let's start off with off to the right, permutation notation. NCR equals n factorial over n minus r factorial r factorial. Same formula as permutation, but with another r factorial on the bottom. And we're doing 10c3 this time, which is, 10 factorial over 10 minus 3 factorial, 3 factorial, and as I've worked out in the notes, that works out to be 120. And it turns out, if we were to have used blanks, blank, comma, blank, comma, blank, well, we would have done the same way as we did for permutations as above, but this thing we would need to divide by exactly the number of ways that we can arrange 3 people, 3 factorial ways, to equal 720, the permutation, divided by the number of ways you can arrange 3 people, 3 factorial, to equal the 120. So big red, we want to see how this number is connected to this number, which is connected to this number, which is connected to the number from above. Again, permutations, particular order matters. P, president example, a great way to remember. P, president, particular order matters. C, committee, as we're going to see later, cards, order doesn't matter. If you get 4 kings in your hand, it doesn't matter the order that you got those kings. C, cards, order doesn't matter. P, president, particular order matters. We're also going to be able to type these things into our calculator if you want to check your answers. Okay, a little on what's called all minus none. So we have 3 boys and 4 girls. I'm going to sum up that information. 3 B's, 4 G's. We're going to sum up information very lazy-like. How many different ways can we make a group of 3 with no restrictions? Well, if no restrictions, we're choosing 7 off to the right. We're choosing 3 of them, and that is equal to 35. Feel free to expand that combination based on the formula and the substitution and the factorials that we've explained earlier. Notice also in the notes there's a different way to do that, but let's leave that as 7C3, the number of ways we can choose from 7 people, 3 of them. Notice it didn't matter that there were boys or girls because there was no restrictions. So, Big Red, remember we're using this information for quite some time, but we are going to start new questions. How many different ways can we make a group of 3 with exactly, so a group of 3, I'm going to circle 3, with exactly 2 boys and 1 girl? Well, we need to, first of all, say how many boys are we choosing from? Well, we're choosing from the given information above in red, 3 boys to choose from, and we're choosing 2 of them. And the fundamental counting principle says that we multiply. And then we're choosing 1 girl. Well, we're choosing 1 girl from 4. 4 choose 1. And we can multiply those together, whatever that works out to be. That's not in the notes. Let me just put that into my calculator here. 3 choose 2 times 4 choose 1 to equal 12. And we could write all those cases out. So what about how many different ways we can do a group of 3? So I'm going to write down 3. Now, quick notation, with at least 1 boy, I just say greater than equal to 1b. Greater than equal to, with at least, we can have just 1 boy. Well, that's cases, and we've talked about cases previously and when they're useful, and sometimes they're useful. So we have cases where we have case 1, number 1, number 2, and number 3. Case 1 is 1 boy. If it's a group of 3, therefore it has to be 2 girls. And we add cases together. Case 2 is 2 boys, therefore a group of 3 is 1 girl. And again, we add cases together, 3 boys, and therefore 0 girls. And notice I'm doing this very linear-like, as I've done in the notes. So, choosing 1 boy from, the case with 1 boy, well, I have 3 boys, the information from above, 3 boys. And I'm choosing 1 of them, and I'm timesing by 4 girls, and I'm choosing 2 of them, and I'm adding 3 boys, I'm choosing 2 of them, times 4 girls, I'm choosing 1 of them, 3 boys, I'm choosing 3 of them, times 4 girls, I'm choosing 0 of them. And as that works out in the notes to be 31, feel free to do those on your calculator or work those out through your factorial notation. We're now going to learn a little bit about all minus none. So all minus none. So instead of adding up 1 boy, 2 boys, 3 boys, so we're still doing the case from above, choosing 3 people with at least 1 boy. And we're doing all minus none. And we're going to do that all. Well, all is the number that we got from above. The total number of ways that we can arrange 7 people in groups of 3, 7C3. Minus none, no boys. None, no boys. 0 boys, therefore 3 girls. So That means we have 3 boys to choose from, and we're choosing 0 of them, times 4 girls to choose from, and we're choosing, therefore, 3 of them. And that works out to be 35 minus 4, which is equal to 31, the same 31 big red that we got from above. So lots of the times it's going to be easier to do all minus none rather than add up all of the individual cases. Let's see where that will come into effect even better. Okay, same page. We now have 10 boys. I'm going to sum up the information at the top. 10 boys and 11 girls. And I want to know how many different ways we can make a group of 10. So I'm going to put an arrow to 10 and I'm going to circle it. This notation isn't perfect. With at least 1 boy, greater than or equal to 1 boy. Well, instead of adding up all the ways with groups of 1 boy, 2 boys, 3 boys, 4 boys, 5 boys, 6 boys, 7 boys, 7 boys, I believe it would be the last case, 7 boys. 8 boys, however many cases. Well, we're just going to do all minus none. The total number of ways that we can arrange 21 people, 21, 10 at a time, and subtract the case of 0 boys, which is going to be 0 boys, therefore 10 girls, a group of 10. We only have 10, we have 11 girls, that means we can only choose 10 of them. So 0 boys, we have 10 boys to choose from, and I'm choosing 0 of them. And I'm multiplying by 11 girls, and I'm choosing 10 of them. And then as you can see from the notes, that works out to be a gigantic number, 352,705. A much easier thing than adding up all those cases as seen in the notes. Okay, one last example about all or none. And before we do that, all or none is a lot simpler than you'd originally think. How many different ways can we get a 5 on a 6-sided dice? So we're rolling a dice, 1, 2, 3. That's the worst dice I've ever seen. So we're rolling a dice, and how many ways can we get a 5? Well, 1 out of 6. Or all minus none. The total number of ways we can get anything is 100% or 1 minus none, no 5s. And that would be a 1, a 2, a 3, a 4, or a 6, which is 5 out of 6, which is also just equal to 1/6. So different ways we can look at all minus none. So in the case at the bottom, a family of 5 takes a family photo. I'm just going to write down the number 5 just because that's given information. How many different ways can the parents not sit together? So maybe the family photo wanted the parents not to sit together for some reason. So I'm going to sum up that information. I'm just going to call the parents P. So the parents cannot be together. So P =/ through it, just summing up the information. So the answer is the total number of ways that the family can sit with no restrictions. So if we have 5 people, that's 5 blanks, or simply 5 factorial, minus the number of ways that they can sit together. So the number of ways that they can sit together, well, we want to think. Let's call the family members 1, 2, 3, 4, and 5. And let's call the parents 1 and 2. Well, how many different ways can they sit together? Well, we now have 4 objects. The parents, 1 and 2, and then each of the kids. So that means we have 4 things to arrange. But then each of those parents, so let's call the 3 kids, each of those parents can sit here, can sit here, can sit here, can sit here. Being one of the 4 things, 4 factorial, the parents being 1 and each of the other kids being 1, 4 things. But then within each of those places, the parents can switch. So we need to multiply that by 2 factorial. And that's exactly what goes over here. 4 factorial, 2 factorial. And that's simply whatever that is. 5 factorial on the calculator, 5 factorial. 120 minus 4 factorial is 24 times 2 factorial will be 48. And minus 120 is equal to 72. 72 family photos that we can make with the parents not sitting together in red. The total number of ways they can sit together, all together, no restrictions on the family, minus 4 factorial, 2 factorial, the number of ways that they have to sit together, done off to the right. All minus none. Use it whenever you can, whenever you need to.